Let's talk about how to factor polynomials. So there are a couple of main ideas here. And the first one is going to be just by doing the greatest common factor. So this is going to be the first method, and it's greatest common factor. And a lot of the times people will abbreviate this with GCF. So the idea for this method is you look for things that all of the terms of your polynomial have in common. So you're looking at each individual term, you're noticing what things they have inside of them, and you want to find what all of them have in common. So let's just do some examples. I think it's best to see it this way. So let's look at example 1. We'll look at 6x cubed plus 45x squared plus 21x. So here we're going to look for things that each of the three terms, 6x cubed, 45x squared, and 21x, what do they all have in common? Well, the first thing that I noticed they all have in common is they all have an x in them. So we could factor out an x for sure. And another thing that they have in common is they all the numbers in front, the 6, the 45, and the 21, they all are divisible by 3. So they all have a factor of 3 in them. So we can also take out a 3. So 3x, that's what the greatest common factor is. It's the thing that all three terms have in common. And now we just look at what's left behind. So we'll put a parenthesis and we'll see what's left. If we take out the 3x from 6x cubed, what's left behind is the 2 and an x squared. And you could check because if you multiply 3x with 2x squared, you get 6x cubed back. For 45x squared, if we factor out a 3x from there, well, if you take out the 3, that leaves 15. And if you take out one of the x's, you just have x. And then from 21x, if you take out the 3, what's left is 7. And if you take out the x, there's no more x's. So we're left with this. So this would be what it is when we have it factored out. You're looking for what they all have in common, and you're just taking it out. And when I say taking it out, I really mean like dividing it out from them. Because when you go backwards and you multiply it, you should get what you started with. Here's another example. We could do x times b squared plus a plus 7 times b squared plus a. So this one's a little more abstract, but it works the same. You can notice that this term, it has an x, and it has a b squared plus a. This term, it has a 7, and it has a b squared plus a. And the question you ask is, what do they have in common? Well, they both have a b squared plus a with them. So you can write this as factor out the b squared plus a. And then you see what's left behind. So if we factor out a b squared plus a from this term, all that's left is an x. So we have x. And if you factor out a b squared plus a from this term, all that's left is a plus 7. So we have plus 7. So this would be what it is factored. Maybe let's do one more example. We could do x to the 4th y squared plus x squared y. And we ask, what do they have in common? This term has an x to the 4th, and this term has an x squared. So together, the thing that they have in common is they both have an x squared inside of them. So we can factor an x squared. The first term also has a y squared, and this term has a y, so we can factor out just a y. And we see what's left behind. If we take away x squared from here, what's left behind is x squared. And then if we take out the y, what's left is a y. And then for this term, if you take away an x squared and you take away a y, all that's left behind is just a 1. Because if you do x squared y times 1, you get x squared y back. So that would be this factor. So for this method of greatest common factors, you're just identifying each term and you're going to take out what they have in common. And in general, this is like a really excellent first thing to do. So if you have a polynomial and you want to factor it, it's best to do the greatest common factor first before you do any of the methods that I'm going to describe later. Actually, I'm just going to do one more method, and it's for a very specific type of polynomial. But yeah, this is greatest common factor. Method 2. This is how you factor things that look like trinomials. So ax squared plus bx plus c. This is called sometimes factoring by grouping, because what we're going to do is we're going to figure out a way to split something up that looks like this in a way where we can then use greatest common factor to make our life easier. So here's what you do. Here's the idea. First, ask yourself what two numbers multiply to a times c and add to b. That's the first step. You ask yourself what two numbers multiply to a times c but add to b. Then use these numbers to split the middle term. And you factor using the greatest common factor. So this is the idea. Lots of words. It'll make more sense if we just do an example or a few examples, I think. So let's do examples. And I'll just illustrate these steps. So let's factor 2x squared plus 5x plus 3. So for this, a is a number in front of x squared, b is a number in front of x, and c is the number without any x's. So a equals 2, b equals 5, and c equals 3. So we want two numbers that multiply to a times c. A is 2 and c is 3, so that means that a times c is 6, because that's 2 times 3. So we want two numbers that multiply to 6 and add to 5. Well, in this case, it's kind of nice. It's just 2 and 3. So it'll be 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So here's what we do with that. We rewrite 2x squared plus 5x plus 3. So we're going to split this 5x using these two numbers, 2 and 3. So we're going to write this like 2x squared plus 2x plus 3x plus 3. The 2 and the 3, that's coming from the fact that those are the two numbers we found when we asked what two numbers multiply to 6 and add to 5. So we have 2x and 3x, 2 and 3. Now you look at it as two separate pieces. We'll look at it the first two terms and the second two terms. What do the first two terms have in common? Well, they both have a 2, and they also both have an x. So we can factor the first one as 2x, and we're left with an x plus 1. And we can factor the next two terms. These have a 3 in common, so we can factor out a 3. So plus 3 times x plus 1. And now, both of these terms have an x plus 1 in them. So we can factor out an x plus 1. When we factor out the x plus 1 from here, all that's left behind is a 2x. And when we factor out an x plus 1 from here, all that's left is a plus 3. So that means that our original polynomial factored looks like this. It's x plus 1 times 2x plus 3. Let's do another one. Let's do this example. 5x squared plus 7x minus 6. So the question we start with, actually maybe let's identify the things first, the a, b, and c. So a is 5, b is 7, c is negative 6. A times c should be 5 times negative 6, which is negative 30. So the question you ask is what two numbers multiply to negative 30 and add to 7. If you're ever unsure, you can honestly just make a list of the factors of negative 30 and see which ones add to 7. So like, for example, negative 15 and 2, those multiply to negative 30, but they don't add to 7. Negative 6 and 5 multiply to negative 30, but they don't add to 7. We've got 10 and negative 3. That should do the job. 10 times negative 3 is negative 30, and 10 plus negative 3 is 7. So it's 10 and negative 3. So what we do, actually, let's do it down here. We use those numbers to split the middle term. So instead of 7x, we're going to write plus 10x minus 3x. Like this. So the 10 and negative 3 are coming from these two numbers that we found. And now we look at the first two terms together and the second two terms together. So the first two terms have a 5 in common, and they also have an x in common. So we could factor out a 5x, and what's left behind is an x plus 2. And these last two terms, they both have a negative 3 in common. So we can take out a minus 3, and we're left with x plus 2. And now these two terms have an x plus 2 in common, so we can factor out x plus 2. And we're left behind with 5x minus 3. So this is what it would be factored. Do even another one maybe. Let's do one more example. We could do 2x squared plus 9x plus 9. So we want two numbers that multiply to 18 and add to 9. 18 because that's what a times c is, and add to 9 because that's what b is. Well, I think that's going to just be 6 and 3. So 6 times 3 is 18, and 6 plus 3 is 9. So we can rewrite it as 2x squared plus 6x plus 3x plus 9. Again, it's the 6 and the 3 because those are the numbers we found up here. And then you go piece by piece. We'll look at this piece, and we'll look at this piece. The first two terms have a 2x in common, so we could write it as 2x. And then we have x plus 3. And the last two terms have a 3 in common. So it'll be x plus 3. And now these two terms have an x plus 3. So we're left with this. So this is the idea of how you factor something that looks like ax squared plus bx plus c. I wanted to show two more examples to illustrate what will happen if it looks like it's something different, but it's not actually that different. So the first one I want to do is if we have something that looks like x squared plus 2x minus 15. In this case, I just want to point out, because it might not be clear, a equals 1, b equals 2, and c equals negative 15. So you still do the same process. Even though a is 1, you find two numbers that multiply to negative 15 and add to 2. That's 5 and negative 3. So then you have x squared plus 5x minus 3x minus 15. And again, you look at the first two together, last two together. So you have x times x plus 5. The last two terms have a negative 3 in common, so you can take out a minus 3, and you're left with x plus 5. So you have x minus 3, x plus 5. So the same strategy works even if a equals 1. So that's that example. And then a similar thing will also work even if b equals 0. So for example, let's do x squared minus 9. Here, a equals 1, b equals 0, and c equals negative 9. A times c is negative 9. So you want two numbers that multiply to negative 9 and add to 0. That's going to be 3 and negative 3. So you can write x squared minus 9 as x squared plus 3x minus 3x minus 9. Again, you do by grouping, so these two together, x times x plus 3 minus 3 times x plus 3, which is x minus 3 times x plus 3. This is actually a very special case. This is actually given a special formula. This is called a difference of squares. If you notice, x squared is something squared, and 9 is also something squared. It's 3 squared. So if you have something that looks like a squared minus b squared, when you factor it, it actually is just a plus b times a minus b. And the one that we just did, it was x squared minus 3 squared. So it becomes x plus 3 times x minus 3, which is what we said the answer is. So this is the idea of factoring. I encourage you to try some practice problems. And yeah, thanks for listening.